So, I'd like to introduce Mark Salamango. He has worked in technology since his first paid programming job when you were about 17, I understand. And since then, he has managed teams, products, and transformations in some of the most innovative places in the United States. Mark received his Bachelor of Science in Computer Science from the University of Michigan and his Master's in Computer Science from Lawrence Tech University. I think you said that was somewhere on the order of 20 years ago, I think?
Yeah, let's go with that.
And at LTU, he studied software architecture and robotics. Mark was selected as Crane's 40 Under 40 and has given a talk at TED Detroit on robotics and won Professional of the Year at Michigan Medicine, among other accolades. He has been the keynote speaker at several conferences and is passionate about using technology to solve problems. Today you're here to talk to us about stories of academics, inspiration, loss, and success, I take it.
That's it. All right, thank you. Thank you. I don't know if you should clap just yet. Why don't we wait till the end, and if it's okay, then you can clap. I wanted to thank everyone for welcoming me to give this talk today. When I was asked, I thought, well, what would be a good thing to talk about to a bunch of students, faculty, and I kind of had to go back several years and think about what it was like when I was a student and what would have helped me. And so I tried to guide the talk around that, and then at the end there's a little bit of maybe an interesting demo if we have time, and if there's questions, we can handle that too. I know that we're competing with another event, and so we may end a little earlier, but just grab me afterwards if you want to ask any questions, and I'm happy to answer whatever I can. So this talk, I'll give you a little bit of an overview. So I'm going to give you just a couple seconds about me. That was a fantastic introduction. It was almost like I wrote it myself. So I am excited about technology. Technology is great, but I think it's the stories where we use technology that really gets people interested. So I'll try to frame everything around stories of things that I've actually done and not just things that I've talked about. We'll talk about academics and where I think there's a potential strategy there for you all. Some inspiration maybe, how you can find some problems to solve, and then I will also share the negative things that have happened, because we're in technology, things don't always work out. And then I will share a story of victory that is kind of ongoing for me right now. So first, about me. I am actually a famous actor. I don't know if you've seen me in this one or not. That was one of my favorites, but I've also done this one, and the abs are absolutely real.
The old ones say
it's a lot of working out, a lot of dedication.
gives testament to our bloodline. His roar is long and loud.
Brilliant dental work. And finally, I did this role. Johnny Depp wasn't available, so I had to fill in for him. I do all my own stunts as well. So obviously, we can talk about AI later, but I am the CTO, Chief Technology Officer, for a company called Fifth Eye. Fifth Eye is an AI analytics company that we kind of focus on streaming waveform data, like high fidelity waveform data, and we turn that into actionable things for clinicians. I was the CIO for part of emergency medicine at the University of Michigan. I was CEO of Robot Town, thanks to some of the stuff I studied here at Lawrence Tech, LTU grad, Michigan grad, all that stuff that we said in the intro. So that's about me. I did that thing too, and that thing, which was fun. All right, so like I said, I'm going to try to wrap stories around everything that we talk about. I think the beautiful thing about stories is if I were just talking about neural nets or fuzzy logic or something like that, CJ would be saying, yeah, he's full of it. He doesn't know what he's talking about. But stories, they're all mine, so you guys can't really judge. And honestly, this is one of the things I would say as you're collecting them over the years, remember them and remember how you applied the things that you've learned to the different stories and things you've accomplished. So on the academic side, I have to start off with a story. I got to be honest, who's into Bluey? You all are, right? I don't care how old you are. All right, come on, fess up. No? Okay, maybe just me. So when I first got my real job where I was an executive, one of the things that I firmly believed is that if you didn't go to MIT or Stanford or the University of Michigan or Carnegie Mellon or one of those places, you weren't right for me. And this is a confession, and I feel bad about it. I have lots of regret over that, because then I started working with some of the smartest, most brilliant, experienced people that I've ever met that went to community college or no college at all. One of my favorite developers I ever worked with didn't go to college at all. He was just very passionate about the things that he was studying, and he just figured this stuff out. So the point here is, I think it's that passion and experience that is what is really going to help you out. So where you can apply the things that you're learning here to places where you can get experience, that's what I'm looking for now. If I need to hire someone, that's the first thing I'm looking at. I was mentioning earlier, we were hiring about 6 months ago. I got 350 resumes. Every single one of them were really great technically, but I needed the people that were passionate and actually had experience that was relevant to what we were doing. So that's what I look for now. The other thing I look for now is domain experience, and this is another thing that a few of the early stragglers learned about me, is that, again, everyone knows how to write code these days, some better than others, but we can talk about that later. But I'm in medicine now, and so if I'm going to hire someone, I want someone who not only knows how to do all the AI stuff, all the development stuff, but I want someone who understands what medicine is about, how doctors work, how hospitals work. Those kinds of things are very important for me. So I guess what I would suggest, and I'll do a recap later, is that if you can get some domain experience in whatever piece of technology or whatever you're interested in, if you're in business, get some of that domain experience as soon as possible. And I think that will help you out. So there's a couple different ways you can go about it. So again, I'm doing the medicine thing right now. When I first started, I don't like blood. I don't like needles. I don't know how I got into this thing. Actually, I was hired to build a data warehouse for the University of Michigan. And I didn't know anything about medicine. So there's a couple different ways I could have approached this. So you can find a doctor who knows a lot about medicine but doesn't understand technology. You can find maybe a doctor who knows a little bit about technology to use as a liaison, or you can try to learn the stuff yourself. And so I tried to do all three, and what I ended up doing here is, this is a PhD computer science friend of mine, and we were the only two ever to go through something called ACLS, Advanced Cardiovascular Life Support, at the University of Michigan that wasn't a clinician. But it was a way that I could kind of narrow that gap between, I knew the technology stuff, I didn't have the domain experience, so I just had to go out and get it myself. So you can find someone that has it, leverage them, you can get it yourself, and so in this case, did it myself. So again, technology without domain experience. For me, at this point, if you want a senior level position or you want to make good money, the big bucks as they say, I think it's important to have some of that experience. And then again, if I find the person, this developer I was talking about that didn't have any college, every night he'd come home from work and all he would work on is he'd write code. He'd write AI subroutines that did different things. He was just really into it. That was more interesting to me than the guy who went to Stanford or Carnegie Mellon and did some things there. So just a couple things on the academic side. So moving on, now that you're smart, what do you do with it? So I think you got to find the right problem, and this is difficult for people, but the reality is there are problems all over. You just have to notice them. So I have a test for you all. So the question is, are you observant? And so in a second, you're going to see a video. And what I would like you to do is to really focus, because most of you are going to miss it. But you need to find out how many times the players wearing white pass the ball. Y'all ready? I believe in you. I do. All right, here we go. I'm going to distract you while this is going on. This is where I would tell a joke if I knew one, but you're all just counting. You're thinking 4 or 5. Am I up to 7 yet? 11? 2? 1, 42, just the ones in the white. We still got it? We're still counting? It's almost done. You're close. I have a good feeling about this crowd. Okay. What numbers did y'all get? Okay. Who had 15? Okay. 16? 17? 18? Okay, the answer is 16. How many people saw the gorilla? All right, so, okay, did everyone hear the question? How many people saw the gorilla? Okay, so a few people raised their hand. How many people did not see the gorilla? Okay. How many people saw one of the people from the white team leave? How many people saw the curtain change colors in the middle? How many people saw the cat walk across at one point? Okay, that's good because there was no cat, so I would have to, I'd have to call someone on that. So the reason I show this is because a lot of times we think we're observant. We think we understand everything that's going on around us, but the reality is you can start to train your brain a little bit to notice problems and then see if there's some way that you can assign the technology or the things that you know to solve those particular problems. So I have a list. It's actually a Google Doc. Every time something frustrates me or I don't like it, I write it down and I think about, is there some way I can use my skill set or my team's or my friends or whoever's skill set to solve this particular problem? And sometimes it's as dumb as every time I'm making breakfast in the morning, I go to this cabinet, then I go to this cabinet, then I do this and I do that. Well, maybe I should just put everything in the same place so that it makes something a little less bad. So try to start identifying these problems, these things that you think you could potentially solve. I'm going to click this one more time. There we go. So an example of this for me is I mentioned I was hired by the University of Michigan to build this data warehouse thing. And to me, data warehouse building is a little bit like accounting. It's not where my passion is. It doesn't I know it's important, it's a good thing. But I asked our director, okay, what is something that we're going to actually do? What can I actually use my skills to do besides just building this technology layer? And he's a medical doctor, an ED doc, and had been for 25 years. And he said, well, I'll tell you what. I can look at right now and I can tell you're not sick. If someone walked in right now bleeding, pass out on the floor, I know that they are sick, right? So not sick and sick. He goes, help me figure out the people in between. And so that was a legit problem where he said, hey, this is an issue that we have in the emergency department. We'd like to be able to solve this problem. It would really change the way we care for people in the future. So that was enough to get us kicked off into saying, okay, now I have a focused problem. I'm going to solve this problem. And while I'm solving that problem, I'm going to build this data warehouse to get data so I can train an analytic, et cetera, et cetera. So sometimes problems will find you, right? You just have to ask for them. Now, there's a book by this guy, Simon Sinek, and I'll have a little link to this at the end. And this is a great book to talk about. There are lots of problems, but if you don't know what the why is of the problem, why are you actually doing things? And if you get a chance to see any of his talks, they're brilliant. For me, that was what resonated in this doctor saying, sometimes these people look fine and then they crash. And the fact that this happens and we don't know that it's going to happen is a problem. And so I started thinking, gosh, people that I love, I don't want that to happen to them. If they're in a hospital, you think that they're okay, and then all of a sudden they go downhill. So for me, that became my why. My why is because I want to be able to care for the people that I love, so I want to build something that can help prevent these problems. There is a warning, however, and I've fallen I've fallen for this one a few times, but I can see how you can get so enamored with technology that you try to apply whatever technology you know to whatever the problem is. AI, I just got back from an AI conference in medicine. Every single booth was talking about, well, it wasn't an AI conference, it was a medical conference, but every single booth talked about AI. AI this, and most of it wasn't true AI, but they were using it as a buzzword, and they were trying to shoehorn this technology into something that may not have even been a problem. So, and I've done this many, many times. As you get passionate about the technology itself, remember there's a why and there's a problem that you're actually trying to solve. All right, so I like to think I'm not perfect. I make a lot of mistakes. We're all going to make mistakes, and let me share with you a few of them that I've made. So I worked for the Department of Defense for the U.S. Army for 11 years, and in that time, I built some really cool things, but I also made a couple little oopsies. So this first one, again, this button, I'm going to press it again. There we go. So this first one, my team built this platform this is pre-iPhone, but it's a little computer that sits in this little vest, and it could do all kinds of things. It was doing mapping and texting and all that kind of stuff before iPhone, before, I think the Razor phone, like the flip phone, was like the most advanced technology of the time. We could control robots with it. There were many things we could do. And so I was so excited. I built this amazing team. We built this incredible software. It was this open architecture. We were so excited. And I brought a couple sergeants in to test this stuff out. And they put the vest on. And I'm like, okay, pretty cool, pretty cool. They put the computer in the vest. And they're like, all right, all right. And then he puts his gloves on, and he starts going like this, looking at me with an angry face. And I'm like, what? He's like, look, dude, I'm out here running with a gun, getting shot at, and you want me to touch these little buttons with gloves on? Okay, so that taught me a few lessons. Number one, get the customer in early when you're doing UI, UX. And number two, just be careful around the sergeants. So, but that was an easy thing to fix, but that was definitely a mistake that has stuck with me. You gotta make sure that you get those customers involved early on. So this is what it ended up looking like. And again, I did some of this for my grad project here, but one of the things that it could do, it could also detect levels of nuclear, chemical, biological warfare agents. And so you can imagine now this is in that same little vest, and now it was very easy to press these buttons. The second one I'll tell you about, I can't use the words, but the big football game that happens once a year that is for the championship. So there was one in Detroit in 2006, and I was fortunate enough to have my team be a part of security for that event. And so that same vest that you saw was deployed there along with something called an ad hoc mesh network. And so mesh networks are, it's a network that has nodes that are able to move in and out of range, and they connect and they heal on their own. And again, this is 2006. This was pretty new at the time. And so we had all these soldiers, all these law enforcement people had these vests on. They were driving around in these golf carts. They were able to see where everyone was. They were able to tell if there were any nuclear, chemical, biological things. And it was fantastic. We had done tests on base. We had done tests all over. Things were working really well. We had each one of these vests kind of lined up to deploy. We had these little they were called breadcrumbs, these little things that help make this ad hoc mesh network work. We had these little nuclear, biological, chemical sensors. Everything was awesome. We were getting lots of positive press from my little team. And then it's Friday before the game. I'm at a wedding, and I start getting frantic calls from my team. They're on site, making sure that all the communication dishes are set, everything's good. It turned out that ESPN and Fox and CBS Sports were very angry with us because our little ad hoc mesh network devices were stomping all over their signal. They could not get any of the reporting out. And so basically they said, we don't care about the security. We don't care about any of this stuff. We need to make sure that we're able to do our telecasts, which I understood. So we had to jump in high gear, and that night, that Friday, we came up with a plan that we could potentially use something called 802.11a, which is like 1990s technology, if we could only find it. So we called every Best Buy on the planet, and we found one a couple hours away that had several of these, like they were just in a warehouse collecting dust. We were able to, check this out, duct tape 802.11a router that could talk to these mesh network devices, and we were able to pull it off. It's not pretty, but it worked, and then we were able to do the security thing, and we were able to catch everything we needed to for the event. So mistake there, yeah, you don't want to mess with the TV stations apparently. But it's something that we would have never thought of. We'd done the testing in a bunch of different places and thought we were good. And in the end, we were able to pull it off, but it was a little stressful for those 12 or so hours. All right, so let me talk about some things that actually went well. Now, we talked about the right knowledge, academics, plus the domain knowledge. We talked about finding your why. Now, I think the next thing is you want to make sure you have the right team. And this is a book that I'm working on. I've been using this phrase, you want sails, not anchors, on your team. So, of course, every boat needs an anchor, but the reality is it only takes one person on a team to really derail what you're doing. And so creating that team, how many in here have done group projects at Lawrence Tech? How many love them? Yeah, I know. I felt the same way. I had some really stinky groups at times, and the idea is great, the concept is great, right? Because in the real world, you're always going to be working on a team. So it's kind of a little bit of a microcosm of the real world, but you always have that one or two or three people on that team that don't want to do their share, they don't know what's going on, they're not prepared, all that kind of stuff. Or you end up with the brilliant jerk. How many people have had that, right? Yeah, I think we've all had that person. So building the right team is really important. Now, I understand that when you're in school, you don't have the opportunity to build your team. Sometimes the team is built for you. But when you get out and you start working and you start managing people, it is so critical. That Super Bowl thing, if I didn't have the right team, I mean, I would have been sucking my thumb, and sitting in the corner rocking back and forth because it just would not have happened. So you just do what you can to make sure you prune the wrong people and try to fill the team with the right kinds of people. And honestly, it may be uncomfortable to have someone that, knows more than you or knows, about something else, but having some diversity of knowledge is a really wonderful thing. Having, again, if you're on a software team or something, having someone that does, art and UI and UX and that kind of thing, having someone who's more of a math or statistics person or whatever, all these things are really great. Again, I look for the passionate folks, but I learned early on that I have to learn how to compromise extremely well. And so I sometimes think my idea is the right way, right? We all feel that. There's something called the Dunning-Kruger effect that you should look up. It's the 5-second version is often we think we know more than we really do. Like turn on any, TV show or whatever, and everyone's got an opinion, right? Most of the time they don't really know what they're talking about. And every team needs a leader. And what I've found is that if you are giving your teammates this purpose, this direction and motivation, things will work out really well for you. So, all right, so that's a little bit of the success thing. So I'm gonna actually show you some of the latest things that I've been working on. We still good? We're good, right? Okay. I know that there's this other event and lunch is gonna be coming in, so I'm gonna lose you all, so I'm gonna try to zoom through this. So Ahi is latest fruit. The latest success is this product that I've been working on for several years. AHI stands for the Analytic for Hemodynamic Instability. That's why we call it AHI. But basically, it's this analytic that can predict what's going to happen to a patient hours before clinicians, doctors notice anything, or before vital signs even show anything. So this was the answer to that why that I mentioned earlier when the doctor said, hey, find me the people in the middle. We were able to do lots of work to be able to do that, and I'll give you a little hint. So as most good experiments start, it's with a person in a tube, all outfitted with lots of different sensors. So what this is we have our challenge about finding these patients, and now we're like, okay, what sensor are we going to use to be able to detect this thing? So in the beginning, we didn't know. So we did all of them, right? This is just about every sensor you can hook up to a human being. And what we did is we put them in this tube that's called a lower body negative pressure chamber. And I know it looks pretty scary, and you would never catch me in one of these things. But what they did is they put you in, and then every 5 minutes they'd increase what's called lower pressure. So the effect to the human body is that it's pulling blood from the top half of your body into your legs. And so over time, every 5 minutes, they'd crank it up and up and up and up. And over the course of 15, 20 minutes, it would be pulling almost all the blood from the top of your body into the bottom of your body, basically simulating something called hypovolemia. Like, as far as your brain and heart are concerned, you're hemorrhaging, you're dying, you're losing blood. And so the interesting thing about being able to do this in a controlled manner is that we were able to plot all of these vital signs that we were collecting, and we were able to determine that there is hidden information in the ECG waveform. So a lot of you probably know what ECG is, the electrocardiogram, right? You see it if you've ever seen any of the medical shows, you see it on the screen. It's doing that, and then it flatlines, right? And everyone goes, oh my gosh, they're dead. So that signal, it turns out, has tons more information than you can detect with your human eye. And so what we were able to do is tons of signal processing on it, feature extraction, and we were able to build what's called a supervised machine learning model that can predict what's going to happen just based on that single waveform. And our FDA clearance and a subsequent publications show that it's hours before our vital signs even show anything. So what does that look like? I'll give you the nerd architecture, high-level architecture diagram real quick. So bedside monitor, right? It's sending those signals. That talks to a gateway device. We have a little component on premise that takes that information, gets it ready, and then it sends it to our cloud, which is AWS, and that's where all the model lives, and we do some additional work on those waveforms. We also can use a patch system, which is, instead of a full ECG, it looks a little bit longer, a little bit bigger than a Band-Aid, fits on their upper left chest, and it does the same thing. It sends us that ECG, and in real time, we're able to come up with these predictions about what's going to happen with the patient. I know that's a high-level picture, and you probably want to know what's all in this box, but join the company, and we'll teach you all that stuff. Okay, so that is the high-level version of the solution. This is what it looks like. So we built it in a responsive way, so you can view it on basically anything in a web browser. And I guess we have a few minutes. I will, if everyone wants a little bit of a demo, I'll show you. Yeah, okay. This is the scary part of the talk, because I got to switch out of presentation mode here, and all right, that wasn't so bad. Now, if I can keep my friends from sending any text messages for me in the next few minutes, we'll be good. All right, so this is actually a unit at the University of Michigan. This is what's called a telemetry step-down unit, and we've changed the name, so even though some of these names look real, they're fake. You're not allowed to do that, it turns out. And so what we're seeing is every 2 minutes, you're going to see a new one of these bars pop up that says what's going on with the patient currently. And then to the right here, this badge is going to say what we think is going to happen in the future. So this patient should be addressed. And what's crazy here is this is 4 hours of data. Likely their vital signs still are showing that they're normal, and they probably look normal as well. But our analytic for the last 2+ hours has been saying that there's something going on with this patient. So this is a huge thing in medicine right now. We know that nurses are leaving, physicians are leaving, and we just can't keep up with the demand of, I almost said customers, but patients is the right word. So being able to detect when something bad is going to happen is important. But similarly, you can see with this patient, they were really bad, and now they're doing well. So we also can learn something from this, like, hey, whatever treatment you're giving this patient is working. So there's nothing else on the market that in real time is able to tell you what's going on with your patients. And so we have a really nice niche here. It's the fact that this is a non-invasive sensor. You're getting really quick, high-fidelity data coming off this system. Now, you may look at something like this and go, what the heck's going on here? What are we showing? Well, the way the human body works is it will constantly try to compensate for something that is happening to it. And often what will happen is you compensate and then it gets back to normal. And the way it compensates sometimes is just it raises your heart rate or your blood pressure changes. But then it can't handle, maybe it's an infection or maybe you're bleeding, and so it fails again. And so we're showing that. And then you get back to a place where you're at homeostasis and then you can't anymore. And so patients that are like this one that go back and forth often end up with this solid red once they can't fight whatever's going on anymore. And then I guess the last thing I'll share about these is for hospitals, one of the biggest things for them right now is throughput. So they want to make sure they get you out as soon as possible, but there is a penalty if they send you out and then you have to come back within a certain amount of time. The way billing works in hospitals is you get a diagnosis, and after that diagnosis happens, a certain pot of money is devoted to curing you of that or dealing with that. Once that money's gone, the hospital has to eat the rest of that cost, and that's a bit of an issue. So if you discharge a patient home and then they come back within 30 days, you're going to get this penalty where the hospital has to basically take care of you. And so if the clinician was going to discharge this patient, I'd say that's probably a bad idea because we're saying bad things are going to happen. But this patient right here, if I click on them, you can see they've been green for a long time, showing that they're stable. Okay, so for at least 24 hours, this patient's been stable. So the idea here is, you know what, maybe they can go home. If you feel like they can go home, we're also saying they look pretty good to us. So this is AHI. It's, we're FDA cleared, which is great. We're in at the University of Michigan. We're doing a pilot with them in the waiting room. We're working really closely with a partner. The University of Colorado has been amazing. We're doing a deployment with them. We've been working with Hurley and a handful of other hospitals within the United States. So we're really excited about it. And for me, the guy who heard the why from Dr. Ward, in 2013, to be able to go through all these steps of building the team, building the analytic, getting it FDA approved, spinning out into a company, getting funded from VCs, and continuing to expand this thing, it's pretty cool. All right, we'll go back to the presentation. We're almost done. Hopefully that excited at least one of you. I know I only want to go to hospitals that have that. I only want my parents to go to the hospitals that have that. All right, so here's a recap. Collect the stories. It's about the journey. Sometimes we get really mired in the day-to-day, and I think we lose kind of the big picture of what the day-to-day is actually doing for you. Every day you go to the gym and you work out and you get that one thing and you're like, hey, I'm not any bigger. It's okay. The journey is what's really important. Same thing with, you're studying, you're learning about a particular thing. All that stuff kind of goes into who you are. So just keep collecting those stories, the good and the bad. I learned more probably from the bad things that have happened in my life than the things that went really smoothly. So really cling to that. Again, academics, they're great. I love learning. I have so many hobbies because I just love continually learning. But I think when you really move the needle is when you apply that stuff to some domain or a real problem. Again, find your why. I think that's critical. Really helpful if you find something that you're passionate about. You're going to make mistakes. Learn. Celebrate your successes. I really believe that if you can do this purpose, direction, motivation thing and find the right team, you have a much better chance of success. And then here you go. Pro tip. All right, you are going to fail. So try to figure out how to build resiliency. I'm talking to my kids about this all the time. When you fail the first time, it's okay. Don't just go sulking in the corner. Use that to build yourself up. And so there's a few things that I believe in. I believe in doing hard things just in life. Take the stairs, not the elevator. Like when you're 44, start training jujitsu, something crazy. And if you want to train with me, I train at 10th Planet in Livonia. There's also a Royal Oak location. If you want to choke me, that's all good. Want to break limbs, that's fun. Do hard things. Last night I did something I've never done before called paddle ball. Never heard of it as a thing. It's not pickleball. It's not racquetball, it's not tennis, it's something kind of in between. This particular group of dudes I've known since elementary school, and every month we get together. This was the 144th month in a row without missing one that we've done something. We've done knife fighting, axe throwing, knocker ball, whirly ball, and now paddle ball. So we try to make sure we're always sharpening each other. You know, iron sharpens iron. It's a good thing to find other people to push you. But it's a hard thing to try new things sometimes. So here's a couple other things. You know, learning something new. Guitar, I also play guitar. Guitar is one of the most humbling things. I'm a sponsored guitar player. I have records, I've done session work, and every single time I pick up that thing, it laughs at me. So try to do other hard things. You know, sign up for a 5K, even if you don't run. Sign up for it and just do it. You're going to struggle, but in the struggle is where you really grow. Every good thing that I've done, there's been struggle, and that's, I think, what's got me where I am. Face of fear. I talked about needles and blood. I wanted to test myself a couple weeks ago because I've had some bad experiences, and so I got a tattoo. Like, okay, I solved at least part of that problem. Lift heavy things is another good one. You know, if you're a homeowner, doing things you don't think you can do on that side is interesting. You could give a talk, because that's a hard thing to do. I know I look super professional and outgoing, and this is, yeah, it's hard, right? You have to prepare. Talking in front of people is a difficult thing, and having uncomfortable conversations, volunteer. The biggest thing is don't let fear stop you from being the amazing people you are. So, like, my friend here wouldn't have said anything about being a computer scientist if it wasn't for his girl, right? So we're gonna fix that. Okay, so a couple books that may be interesting to you, and if you want to scan this and friend me on LinkedIn, I basically ignore most people, but if y'all grab me, I'll jump on that in the next couple days. Extreme Ownership is one of the best books I've read. If you haven't read that one, it's fantastic. That's one of the things that I believe is that when you screw up, you got to raise your hand and say, I screwed up, this was on me, but also know how to help other people when they make those mistakes. Simon Sinek's Start with the Why. If you're looking for the problem that you want to solve, I think that's one of the best books. And then The Obstacle is the Way is also a fantastic book for just learning about a bunch of examples of people who have struggled, and they've taken that struggle and they've made it who they are. They've overcome and made themselves stronger. I think that's it. So I would be delighted to take any questions you have if you have them. Otherwise, there's likely food and other things. I tried to speed through this. I could probably talk about each one of those steps for about an hour, but any questions? Oh, right. Oh, we got one right away from the big dog.
Actually, I'm very curious about your technology. I don't know how much you're willing to share. But you talked about a lot of the different sensors you were using in order to do work with AHI there. Didn't look like you were involving much in the way of vision at this point, and I expect there's big privacy issues associated with it. However, are there signals from vision that you would like to get in?
Yeah, I'll talk about that. So vision isn't something that we did a lot with on this project, but one of the things that we did in our lab is we were basically taking CT scans, and we built some analytics where you could detect hemorrhage and things like that within the CT scans, because this is another huge issue. Like I mentioned before, there's projected to be way fewer physicians in the next decade than we really need, and so leveraging technology to solve some of those problems is important. And a lot of smaller hospitals don't have radiologists that are on call 24/7. So building these tools that could look through a set of CT scan and be able to detect certain things is really important. So we built a tool that does just that, and it works really well. Now there are other ones coming on the market where people are starting to deploy those. We decided to spin out this other company first, but it is important. AHI currently doesn't use anything else but just ECG. vision. I'd be interested in hearing your thoughts about how we might use vision for something like that. Any other questions about getting jobs, landing jobs? All right, who's got it? I know the YouTubes won't be able to hear you if we don't do this on the microphone, so.
Thanks for the talk. It's really interesting. So I'm not a technologist. I'm a humanist. But I am interested in the way your new technology is sort of like reading that data. And I wanted to, if I could use the video we watched as an analogy. So are you using, I'm assuming AI is involved, maybe not. Are you thinking of it more as getting better at seeing how many white balls are passed, or seeing the grill that's passing in the back of the room? Like, I'm interested in those two sort of attention models.
Right, so not a perfect metaphor, the ball thing, but that's okay. So I use that mostly because when I talk to people, often they're like, well, I don't know what problem to solve, right? I don't know where are the problems. And what I'm trying to explain is that, yeah, we don't see them. We're usually, it's because we're looking at the TikTok or we're doing whatever. You got to say the TikTok, right? We just focus on all these things and we miss so many things that are going on around us. So what I'm trying to get people to do is notice that there are so many things we could be working on. Now, as far as our analytic, it is absolutely using AI. What it uses is something called supervised machine learning. So what we were able to do is take a whole, like thousands of patients of ECG signals and have doctors go through the patient stays and they label where the patients were doing poorly. And we used that to label. We built tools that did all this stuff, but you'd label all that data and you use that to build this model. And there are lots of awesome technology goes into that. Just, it sounds, fairly straightforward, but we had to do tons of signal processing to ECGs. If you ever see them on TV, they always look like this pristine, perfect thing. But in reality, it's like all kinds of noise, and they do something called baseline drift, where instead of just going across, they're going up and they're moving down and all kinds of stuff. So there's all kinds of things we have to do to clean the signal, send it in, and then, of course, the model is important too. So hopefully that helps. I like that you're you came to a talk that hopefully you got something out of it, even though it wasn't AI.
So kind of a follow-up question, which is, you mentioned how much the machines can learn from the experts, right? And so one of the things that I'm constantly thinking about is that this could be so much more powerful if it was truly iterative. So right now, one of the issues that I see is that we don't know what AI is, right? And so trying to figure out how to get AI to talk back to the experts so that we can then close that, right? Is there any work being done in that area?
Another good question. So one of the problems that we have in medicine, at least, is everything has to be FDA approved. And AI is, yeah, and that is honestly, out of all the things we did, I think the FDA part was the hardest. I mean, the technology is easy. Going through all the FDA clearances and setting up the studies for that and going through all the paperwork is maybe the harder thing. But at the time we were doing this, two things came up. One is that the FDA did not know how to handle this thing that continually learned. So they were like, you need to do a static model. And that's fine. It turned out our model behaved so well and was so accurate that we didn't feel the need to keep iterating. But the other thing is you need to get buy-in from clinicians. And clinicians don't want a black box that they don't know what's happening. So we can explain exactly what's happening, how it's been proven, retrospectively, prospectively, and we can show them all the data to prove that happens. So now that's not to say that we're not continually talking to clinicians to say, hey, if there was another signal we could add or something else we could do with the UI, or is it too sensitive, is it too specific, those kinds of things. We're always listening to those things, but every time you make a change, the FDA goes, okay, you gotta file again, you gotta file again. And it turned out when we were filing the first time, there's a couple processes that the FDA uses. What they try to do is find a technology that's similar to what you're doing, and then they use that, they call that a predicate, and then you gotta prove that you do basically what that other one does, maybe slightly differently. And that's a faster process. They call that a 510K process. at first the FDA said, well, you're kind of like this. And so we were trying to prove that. And like, well, you're really not like that. And then they're like, you're kind of like this. And we're like, no, we don't think we are. And they're like, yeah, you are. And then we tried it, and they're okay, you're not. So we wasted a lot of time doing that. And finally, they had to open up a whole new category for us, which is cool because we're the only one in the category right now. We're literally the only product that does this. But it took an awful long time to make that happen. So. It's something like adjunctive. You know what? I'm the CTO. I should know that, but I repress as much of that as I possibly can. But yeah, it has to do with AI and being an adjunctive hemodynamic monitoring system or something like that. I'm going to be in trouble. My boss is going to see this on the YouTube, and he's going to say, Mark doesn't even know the category. Thank you. We'll cut that part out, right? Yeah. Yeah, sure.
So you're the founder, you have a boss? Yeah. You're the founder and you have a boss that's the CEO? Yeah. So you could be fired from your own company?
I could be. Yeah, the board would probably have a say in that, but yeah.
So my question is to ask for your input. So you're a graduate of Lawrence Tech. So you had our core curriculum and you are a graduate of the College of Arts and Sciences. And with the fact that your company is very technological, and we are very excited about AI and technology, but speak to the need, if you think there is one, that today students need to find a way to leverage the humanity, the human skills, the piece that I think is getting lost as we get so excited about AI. And how does that impact your company, and what are some challenges you're having in hiring people that maybe are so technological but they can't work with people, or they're not good in teams, or they don't communicate well? And I'd just be curious your input in all that.
Yeah. Wow. There's a lot there, and I'm passionate about that. So one of the reasons I decided to go to Lawrence Tech in the first place is because I had heard about the fact that a lot of the curriculum was actually doing the thing and not just studying the technology piece. You were actually applying what you were learning. So the University of Michigan was great for undergrad. It taught me so much. I learned how to think. I learned how to study my brains out. But I didn't apply it that much. The projects were they didn't feel like they were they just seemed like lame projects for the most part. And when I came here, the projects were real world projects with a team, which again, that was one of the hardest things, these group projects. But I think that's one thing that Lawrence Tech has going for it. And I tell this to everyone I know. It's like, if you're gonna go to Lawrence Tech, you're gonna build stuff that actually matters, that you can relate to something. In fact, I know people that have used the things that they've done on their capstone, on their resume, and that experience has helped to get jobs. So I think that's great. You hit on one of my biggest problems as I'm hiring people. Again, I mentioned in the talk, if they don't have domain experience, that's a problem. But more importantly, if you can't work on a team, you can't communicate, you have a dialogue with the people on your team and have a discussion about, like have differing opinions and then figure out how to come to consensus, I don't really want you. And so a lot of times for our developers and technology people, we'll give them a test to prove the technology skills, but I'm always the one that does the interview where it's like, don't think they're gonna work on the team. They're either that brilliant jerk I mentioned, or they have this ego that we don't think we can deal with, or they're kind of a loner. You find that a lot. You find these amazing introverted people that are great, but the reality is, as great as you are, you'll be better if you figure out how to work on the team. And that's not just a given. And I don't know if that ends up being something that you learn when you do sports as a kid or where it comes from, but it is difficult to find the right teams. I've had 2 stellar teams in my 30-year career in IT. The rest have fallen short in some way. I'll give you another story. So we had one of the companies I worked with. We had a team actually several teams in Ukraine, and they were awesome. Some of the best developers, just fantastic to work with, but they're in Ukraine. And so it was often this like it was before Zoom even, it was like these Skype calls, we'd go back and forth, and it so much got lost in translation. And then I flew out to Ukraine for a couple weeks at a time, and instantly things got better because we were face to face. I could see they're a human, they could see I'm a human, and it started to work really well. So there's not really a shortcut. You got to put in the time. You got to do some emotional investing with each of the people that you're working with. But it is difficult. There isn't a silver bullet there. I find that you're not likely to change someone too much, so I know pretty quickly if they're going to fit in the culture of the team. Hopefully that answers some of the questions. I wish I had that. Like, it's a class. You do trust falls, and then you're done, and everything's good. You know, do the high ropes course, and yeah, all those things help, I think. I guess the other thing is when you find people that have similar interests, that helps a lot too. And I know you lose something with that though too. If you find a bunch of dudes that are just into UFC and MMA, that's cool for a bit, but you miss out on some other pieces. And so it's a balance between the diversity and what you can accomplish as a team. All right. Oh, you're going to make me go all that way. It's okay. I didn't work out today yet.
Thank you for the talk. The first thing that you said when you prepared this talk is, I'm preparing it to help students, because that's what you mentioned. And almost the first thing that you went through, like under the academic part of your talk, is that knowledge without domain is nothing, practically, or not useful. What is your message to our students? Be prepared to work in one domain for the next 10, 20 years of your career, or before you apply for jobs, get some domain experience, because most of the students will graduate practically with no domain experience.
Yeah. Good question. I think that it is tough when you're just starting out, right? Because you have none. But if you're interested in medicine, for example, and this is another reason I thought Lawrence Tech was great, this capstone idea I think is brilliant. Hopefully that still happens. Okay, so I know that when I was doing the capstone with Dr. Chung, it was great because he said, what do you want to do? And I said, well, hey, I'm working on this thing on the Department of Defense side and for the Army. Can I turn that into something? And we worked together to make that happen. I suspect that if you were interested in medicine or you were interested in investing or something like that, you'd be able to craft a project that gave you some of that domain experience alongside the technical piece that you're working. So that to me is like a freebie, right? You're getting that experience. You can put that on your resume and say, hey, I built this particular thing. And to me, as a guy who's hiring, if I see, hey, he built investment software or farming software or agriculture, whatever, to me that's something. It's not going to win you the job necessarily over someone who's been doing something for 20 years or who has has been working at a hospital or something, but it is something. The other thing, like I mentioned to you, if you can get an internship anywhere in the field that you're looking, again, if you want to do technology for medicine, find a hospital that's looking for interns. They all are. Government does lots with internships as well. So, I got my start. My undergrad was paid for by the U.S. Army because I worked there for a summer. They liked me, and we went from there. So there's lots of opportunities. I do know it's hard. That first resume you send out is a terrible thing out of high school, right? It's like, yeah, I graduated with the 3.5 and I was on the swim team. But you just accrue it over time and you accrue the stories. And so my recommendation is, look, if you ain't got it, that's okay. But if you do have it, it's going to elevate you with respect to the other people that are competing. We'll get my run in again. I hear there's pizza, so.
So as I was listening to your talk, I thought about some of the contrasting technologies that are out there, like DNA splicing and repairing. When you think about conversions with your technology, is there anything that is contrasting or offset that you feel like you're, I don't know, what you're willing to share as far as R&D?
I think that's another excellent domain. If someone's interested in biology, that you start to learn some of those things, because none of that research is possible without computers. It's possible, but it's kind of the slow way around, right? So if I'm understanding your question correctly, it's all related. At the foundational level of just about everything we do, I think, is going to have, there's going to be computer science in there, there's going to be EE, there's going to be ME. It's just a matter of figuring out how you apply it to solve some of these problems. I know one of the big things with big data, which was the buzzwords a couple years ago, was because all these genomes are being sequenced right now, right? And that takes a lot of time, a lot of space, a lot of processing. And so figuring out clever ways of doing that stuff is pretty important. If you look at NVIDIA right now, they've been a rocket ship. I don't know if anyone's following NVIDIA, but over the last 15 years, they were the graphics card company, right? Everyone was buying their gaming computers with NVIDIA cards were kind of the thing, right? Well, they took a nice little turn years ago, and they started just focusing on using these GPUs for AI. And so it's brilliant what they've done and how they're doing it, because again, not to use AI as if you're a hammer, everything looks like a nail, but there is a lot of opportunity to make some of this genetic stuff go quicker, and yeah, hopefully that gets some of it. What else we got? All right. Uh-oh. From my former boss.
Mark, I have a question for you. Do you remember the team name in year 2005?
I didn't even remember what year I graduated. Are you kidding me?
Do you remember the robot we all built?
I remember.
And we went to Traverse City, and the robot got fired. Remember?
Well, my robot didn't catch fire. That must have been a different year.
Yeah. Anyway, thank you so much for coming here today. And I have another question. Why Fifth Eye?
Okay. Everyone asks about the name. So this is a good question. Well, there's a couple different reasons we thought this was a good name for a product. Number one, there are typically 4 vital signs, and so we're kind of like the 5th one. But then we also but you have 2 eyes of the doctor, 2 eyes of the nurse, kind of a 5th eye there. Another thing is when you're starting a company, you need a domain name. So I'm not going to say that was the number one reason we called it that. I like having a number in the name. That seemed to make sense. There's a couple other reasons I think that we could kind of talk about, and maybe they apply, maybe they don't. But yeah, we like the way it sounded too. So yeah, what's that? Yeah, the bar chord. There you go. Another guitar guy. I love it. Any other question? I think you had one, right? Or did we answer it already? Or did I tap dance around it?
Actually, we were talking a bit earlier about how to get more women into technology development. And then you brought up during the question and answer phase about how you were sort of establishing culture fit for your team. And in my experience, at least with the women I've known who have struggled to get into technology field, it's that exact culture fit that makes it an impossible bar for them to get through. How have you, do you have any experience trying to overcome that? What have you doing to try to overcome that particular problem?
Yeah, this is another one. It's a big problem, right? And I don't know as though there's a really great answer. I've worked with some amazing women on the teams that I've worked with, and they all tend to have, I can't even say all, because some are a little bit more introverted, but they're really good at this one thing, and because they're good at that one thing, we want them on the team. I think that the culture of a team is just something that takes time to build, and so I like the idea of giving everyone a chance to make that happen. But the problem that I typically have is I have a specific need, and it needs to be done next week, and so we got to get the person hired, get them up to speed, make it happen. And so yeah, it's a difficult thing. At least where I'm at in the company that I'm at now, where you're at on the, I think you're going to be the ones that help change that in the future, because we just got to make an invite. Like, I have 2 daughters, and neither of them went down the technology route. One's in PT school, and one's a special ed teacher. And while we had all the technology stuff, I have all the nerd stuff at my house. I also have all the recording studio stuff, and none of them picked up an instrument. So I don't know, I'm a failure as a father, apparently. But yeah, I think that schools are going to be what we're going to have to rely on to get, get people interested. And there is a, maybe there's just a, yeah, I guess I don't have a really good answer on that one. I wish I had something better. Our first CEO was a woman, super strong, great at raising money. We've had many women on our team, but I don't know what draws them. And every single one of them we've gotten along with, and it's been a good cultural fit. It's just I don't know how we landed them versus other people, to be honest with you. Some of it is right place, right time, networking events and stuff like that. You see someone you hit it off with, and then you just say, hey, let's work together. So, yeah, sorry. I wish I had something better on that one. I really don't. All right, he's going to ask me another tough one.
No, it's not. Have you heard about SBIR, Small Business Innovate Research Program? And are you interested in working with us, with our students? Do you have some ideas for that?
The question was, have I heard of SBIR? Yeah, actually, I ran a program for the Department of Defense on SBIR, so it's always something that we're thinking about. If there's the right fit, then it'd be something that we'd love to do. So STTRs, SBIRs, all those are great. Cool. Thank you all for letting me talk to you for this time. If you want to chat afterwards, I'll be hanging out until, unless my boss fires me. So thank you.